for example, find the exact value of each expression. On part A here, I give you sine of tan inverse of 7 over 24. I want the exact value. Right? I don't know exactly what tan inverse of 7 over 24 is. I don't know. It's not one of my special numbers on you. So instead of going at this brute force and trying to figure out what tan inverse of 7 over 24 is, I'm going to be a little more slick. I'm going to think, okay, well, I know tan inverse is an angle. Right? That's what tan inverse does. It takes in a ratio, but altogether it spits out an angle. This whole thing is an angle. Call it theta. And what does that angle have to satisfy? Like, what do I know about? What equation do I get from tan inverse? How do I change that into a tangent equation? Tan theta has to equal 7 over 24. So I'm kind of looking for clues here from this expression, and one of them is this inside part is an angle, and it satisfies the equation tan theta has to equal 7 over 24. So what the question is ultimately asking is, given that tan theta equals 7 over 24, find sine of theta. So the biggest battle in this problem is deconstructing it into a question you can answer. And the way that you answered this question in previous sections for me was to draw a triangle. Because at least that's one way. If you know tangent is 7 over 24, you know opposite over adjacent. So you can draw a triangle, and then you can find sine by doing opposite over hypotenuse. So the trick at this point, once you've rephrased the question, is to draw a triangle. You have to be careful about the quadrant. I need to figure out, before I draw this triangle, whether my angle is in quadrant 1, 2, 3, or 4. Right? Because if it's in quadrant 2, I get negative signs different than if it's in quadrant 1 or 4. So the quadrant of theta comes down to two things. One of them is going to be the fact that tangent is positive. Tangent is equal to a positive number. Right? There's no negative sign here. So one fact is that tangent is positive for this problem. Which just comes from the fact that this number here is positive. That actually narrows me down to two quadrants. Which two quadrants is tangent positive in?
1 and 3.
1 and 3. So tangent being positive puts me here. But, excuse me. But that's not enough, right? Because I need to decide between 1 and 3. So how can I narrow it down? Yeah, the restriction. What? Now don't worry about sign. Okay, I don't know. I'm trying to find sine, so I have no idea whether sine's positive or negative, right? It's what I'm trying to find. So this guy actually doesn't tell you anything. But this guy tells you something. Right? What's tan inverse always between? Negative pi over 2 and pi over 2. So the second fact you need for the quadrant of theta is that tan inverse is between negative pi over 2 and pi over 2. So this is negative pi over 2. This is pi over 2. Which means tan inverse ends up over here or over here. overlap is in quadrant 1. So every time you're dealing with this mix of trig functions, one inverse, one non-inverse, you're going to have to find the quadrant that your angle is in, and the quadrant always comes down to the sign of this number, positive or negative, and the range of this inverse function. The fact that this number was positive told us tangent's positive, 1 or 3. The fact that we even had a tangent inverse to begin with tells us between negative pi over 2 and pi over 2. So then I can draw my triangle and answer this question. Our triangle is going to have to be in quadrant 1. So I put a nice right triangle in quadrant 1. What do I label the side lengths on this bad boy? Opposite is the top here, adjacent is the bottom. So using this tangent ratio, I can label my opposite 7 and my adjacent 24. Then you do your Pythagorean theorem. You should get 25. Right. So this guy, you got to do Pythagorean theorem. Once you label that, then you can read off sine. What's your sine value? 7 over 25. Which means that sine of theta, which is what we were looking for, is the same thing as sine of tangent inverse of 7 over 24. And that's what we just found. 7 over 24. You don't have to write this, just for completeness. This is what we're looking for. You can write this. So this is really, when you have a trig function and then an inverse trig function inside, this is a triangle problem. This is encoding the triangle problems which we did in 6.3. What do you think? Easy or hard? Both easy and hard.
So if the tan wasn't inverse, then it would be a ratio. And would we do it differently? If it was ratio?
You can't do anything then. I mean, if it's tan of some, okay, so if tan's not inverse, then this thing in here is an angle. Whatever you want to make it, 18 pi over 30. And then you would have to put your inverse out here.
Should I not worry about it?
Yeah, I mean, I'd have to sit down and think about how to do this problem. I don't know that you can do this without. I don't know if you can find the exact value of this. So for all of these problems where they're mixed, the inverse is going to be inside, and the original function is going to be outside.
But like, if the inverse, like if it was inverse sine in there, then it would end up being a ratio as well.
Yeah, but if it's sine inverse, we use a little bit different.
Oh, let's say it wasn't. Let's say it was cosine then on the inside.
Here?
Yeah, like cosine inverse.
Yeah.
Then it would be a ratio, right?
This we can do. We'll do the same
You
we
can still
did.
solve it the same way, even though it's a ratio, not an angle.
No, this is an angle.
Oh, that's an angle.
This is a ratio. The input's a ratio. The output, the whole thing is a ratio.
Oh, so.
See the difference? When I write cosine of 3 pi over 2 equals 0, this is an angle. But the whole thing, the result, is a ratio. So when you write cos inverse, the first part, the input right here is a ratio, but the result, the answer to this is an angle.
So 7/24 would be a ratio,
Yes.
whereas
Whatever the answer to this
inverse
is.
cosine would be the angle.
Yes. But we don't know. I don't know what it is. I don't know what the inverse cosine 7/24 is. That's why I label my angle a variable thing. So let's try and so part B here, I give you tangent of cos inverse of -1/4. So let's see what's the setup here. So the first thing you want to do is try to rephrase this problem into something you can tackle. So I'm going to note that this whole cos inverse is an angle, theta. And it tells me that, what equation does it tell me? Cos of theta has to equal so this is, I know this, I'm given this. What do I need to find? Tangent. Right, because tangent's on the outside. Which means I can draw a triangle, use the fact that this is adjacent over hypotenuse to label my triangle. But I have to first figure out the quadrant that I should draw my triangle in so I get all the correct signs. So how do I figure out the quadrant? Yeah, so there's two things. First, cosine is negative. So if I were making a little diagram, I would say, all right, which quadrants is cosine negative? 2 and 3. Cosine is the x value on your unit circle, so you can go wherever x is negative. And then what's the other thing I need? Cos inverse. That I'm dealing with cos inverse gives me a range of angles. So cos inverse is always between what and what? 0 and pi. So here's 0 radians. Here's pi radians. Cos inverse has to be between. So what's my quadrant of theta here? So then I stick my triangle in quadrant 2. Label my side lengths. Adjacent hypotenuse. Hypotenuse is 4, adjacent is -1. Since this guy is going up, he's going to be positive. Okay? And how do I find it? Pythagorean theorem. -1 squared plus this side squared equals 4 squared. So what do you get? Root 15. Right, because this is 16, you have to subtract 1. Positive because you're going up. Right? It's a positive y direction. We're looking for tan theta. Opposite over adjacent. So the tangent of the cosine inverse of negative 1/4 is negative root 15. Maybe one more. One more with an X in it. All right, so I'm mixing here, in this example, I'm mixing sine and tan inverse, right? I want you to find and simplify sine of tan inverse, but I give you X instead of an actual number inside. So you're going to mirror all the same steps, you're just going to do it with an X. So, should be okay. If we want to rewrite this as a ratio, what's the first thing we have to do? Yeah, first you have to say, okay, well this is an angle, and I know that it's the angle that makes tan of theta equal to X. Oh, but that's not a fraction. What do we do about that? Right, because we like fractions so we can say opposite over adjacent. Right, hypotenuse over... Put it over 1. And then I have an opposite and an adjacent. So given this, I want to find sine theta, right? Since sine is on the outside. So I draw a triangle. But I have to make sure I have the correct quadrant of the triangle. What's the quadrant come down to here? So now you got to be a little careful here because first you need the sine of tangent, SIGN. Right? When you're looking for the quadrant of theta, you say, okay, well tangent is either positive or negative. How do I know tangent is positive here? Because it says x is positive. If I say x, right, it says it in the problem. Assume x is positive. If I say assume x is negative, then tangent would be negative and you have a different quadrant situation. So in the problem it said, assume x positive. That's how I do this. Right, tangent's equal to x and x is 1. What's my other piece of information that I care about? The inverse. Tan inverse is between what and what?
Negative.
Yeah. So when I do my little diagram to narrow things down, the fact that tangent is positive puts me in 1 or 3. And the fact that I'm between negative pi over 2 and pi over 2 puts me in 1 or 4. So I end up again. Draw my triangle in quadrant 1. What do I label my sides? Opposite is x, adjacent is 1. Opposite x, adjacent 1. How do I get the hypotenuse? Pythagorean theorem. Now, you're not going to be able to simplify it very much because you have an x instead of a number. Right? But you're going to have to calculate 1 squared plus x squared equals c squared, the hypotenuse. And then you solve for c squared by what? How do you get rid of the, solve for c, I mean, how do you get rid of the square? The square root. So I have to take the square root of both sides to get rid of that. So c is actually equal to the square root of 1 plus x squared. Can I simplify this? 1 plus x? 1 plus x? No. Why not? Addition. Right? Square roots do not play nicely with addition signs.
I have a question.
I have an answer.
How come the 2 carried over to the x, but it didn't carry over on the 1?
Because I know what 1 squared is. What's 1 squared? I can't simplify this one because I don't know what x is. But here I actually calculated it. I said 1 times 1. So what am I looking for here? Sine theta. What's my sine of theta? X over square root of 1 plus x squared. No, God, no. Look. Why? Yes, that's a good point. Because it doesn't look pretty. I understand that point. Except when you actually rationalize here, if you multiply by root 1 plus x squared and root 1 plus x squared, you get x root 1 plus x squared over 1 plus x squared. Which doesn't look any prettier.
Okay.
So, honestly, it blows my mind when you rationalize and when you don't rationalize as far as textbooks are concerned. This is more, kind of the cutoff is what I found is once you get into calculus, the textbooks kind of don't care about rationalizing and you just leave them. Okay? But before that, they want you to rationalize. In this case, I think it's just so ugly that rationalizing doesn't make it any prettier, so let's not worry about it too much.
Okay.
I'll accept either answer. If you put this, I'll accept it. I won't want it wrong. But, and if you're ever at a loss and you don't know, you can ask me, Josh, should I rationalize this? I'll tell you. But this is where I was. Okay. So when you're mixing the trig function, a trig function with an inverse trig function, but they're not the same, you draw a triangle. Okay, the whole trick is making sure your triangle's in the correct quadrant. If you're ever doing one of these problems and you end up with a triangle in the third quadrant, how do you know that's garbage? Because all of your inverse functions, all 3 of the inverse functions we talked about, never go into the third quadrant. Right? Sine and tangent inverse stay here. And cosine inverse stays here. So if you have a problem with an inverse function in it like this, you're never going to get into the third quadrant. But you can land in any other one. So I guess if you do it on a quiz, you have a 1/3 shot of getting it right. If you don't use, math.